All right, ladies and gentlemen, we are on section 12.4. This is your first video for the week that you need to watch, and it is on tangents and segments. So we've talked about tangents as they relate to angles in the previous chapter. We're going to talk now about how do they relate to different segments. So it says in a plane, there we go. In a plane, a line is tangent to a circle if and only if the line is, if we remember what that symbol means, that is perpendicular. Okay, so remember, tangent means it intersects the circle in only one spot there. And if that is the case and it's connected to a radius, it's got to be perpendicular. Okay, so our first example that we're going to do here is out of order, example 4, but it says in the diagram RS is a radius of circle R. Is ST tangent to OR? So what I'm asking is this segment right here, if I were to extend this out as a line or a ray or whatever, I want to know, is that tangent? Okay, now our previous theorem said the only way that is true is if this is a right angle. So we're going to have to go back a couple of chapters and think about how did we determine if something was a right triangle, and that was like the converse of the Pythagorean theorem. So what I'm thinking is 26 squared, we're going to go, how does that compare to 24 squared plus 10 squared? Okay, 26 squared gives me 676, and I'm going to put a question mark here just in case you don't remember. Like, we're trying to see, is it greater than, is it less than, is it equal to, what may it be? Okay, 676 blank, 24 squared plus 10 squared gives me 576 plus 100. 676 is equal to 676, so this is a check, yes. Segment, TS, is tangent. Okay, so that's converse of the Pythagorean theorem, just to double check that. Okay, so are they a radius now? Or no, RS is a radius of circle R. Is ST tangent to circle R? So exact same idea here. I'm going to be thinking is this one, we've got to be careful here. Okay, this 8 is only that distance there. Okay, so we've got to think about what would this distance in red be, and since that's also a radius, I can say that that's also 5. So this entire thing is 13. Now, if we do Pythagorean theorem or converse and think how does that compare to 5 squared plus 12 squared, some of you guys probably remember the special relationship of a 5, 12, 13 triangle. So this one is a yes. Okay, it does come out as 169 is equal to 169. Okay, next one, same idea here. I know that the radius is 12, so I've got to add in that 12 right there, which makes this entire thing 19. So I'm going to compare 19 squared. How does that compare to 12 squared plus 16 squared? 19 squared gives us 361. 12 squared is 144. 16 squared is 256. And I get that over here 361. Over here I get, what, 400? This does not equal 400. So this is a no. Now, if you remember when we first learned converse of the Pythagorean theorem, we would have said that that was less than, which meant it was an acute triangle. But that doesn't matter here. Okay, we don't have to worry about is it acute or is it obtuse. It's just, is it tangent or is it not? As soon as it's not equal, it is a no. Okay, so this segment right here is not a tangent. It hits the circle in more than one spot if we were able to zoom in super duper close. Okay, so the next example is something more like what you might see on the test here. So it says in the diagram, B is a point of tangency. So I know this is a tangent. Find the radius R of the circle, C. So since that is tangent to and the radius connects to it, I know that this is a right angle. So what we can do here is use our Pythagorean theorem. So the Pythagorean theorem, I'm going to start with my large side. That entire side length, excuse me, is going to be 49 plus R. Quantity squared is equal to R squared plus 77 squared. So my two legs, and I'll draw those in purple there. Okay, now if we multiply 49 plus R times itself, that's what it means to square. So this is really like 49 plus R, plus R, times 49 plus r is equal to, over here I could do 77 or r squared plus 77 squared. 77 squared gets me 5,429. Let me just double check that because I wrote pretty sloppy on my notes here. 5,929. Okay. Glad I checked that. 5,929. Okay, if I multiply out on the left-hand side, first outside, inside, last, 49 times 49 is going to give you 2401. Inside is going to give you plus 49r. Outside is going to give me plus 49r. And again, guys, we're just foiling here. And then it's going to be plus r squared. Now, all of that is coming from right there. Okay, is equal to r squared. I forgot my plus sign up there, plus 5929. Now, you might think, holy cow, Mr. Cieslak, that looks really ugly to solve. Here's the nice thing. Notice I've got an r squared and an r squared here. They're gone. As soon as I move those over, they just cancel. So on the left, all I have is 2401 plus 49 plus 49 is 98r is equal to 5,929. I can subtract 2401. So I'm going to get 98r is equal to, that comes out as 3,528. Divide both sides by 98. And I'm going to come up with an r value of 36. Now, technically, we should label that units because it's just a linear measurement. Okay, so that's the idea on that one. So, theorem 10.2, the last one we have, I think, in this section, is that if tangent segments from a common point, or from a common external point, let me say that again. If two tangents have a common external point, so in other words, S, they have that vertex there, you can think of it as, and if I know that this is a tangent and this is a tangent, then I know the two segments are congruent. Okay, so both of these are tangent here. It tells us that in the directions. It says find the value of x. That's as simple as setting them equal. 3x plus 5 is equal to 32. So I'm going to get 3x is equal to, subtracting 5, I get 3x is equal to 27. I would say x is equal to 9. You can always go back and double check. 3 times 9 is 27, plus 5 gives me 32. So we're good there. How many more problems do I have? Okay, since there's only 2 more here, I would like you guys to pause the video and give this a try on your own. I'll work through them and then unpause it and see if you guys got the same thing. So, in the one on the right, I'm going to start with r plus 32, because that's my hypotenuse. Squared is equal to, it's going to be r squared plus 56 squared. So this is going to give me, on the right, r squared plus 56 squared gives me 3136, all equal to, I'm going to just, on this line, write r plus 32, because I got to FOIL it. So you're going to give me r squared plus, now I'm combining the outside and inside, because outside gives me 32r, inside gives me 32r. So I'm going to jump right to that just being r squared plus 64r. And then 32 times 32 gives you, I believe, what, 1024? Yep. So plus 1024. Again, looks really ugly, but if I combine the r squareds, I move one over, they're gone. This, I made a mistake here. Don't do that. That's not an r squared, because it would be plus 32r plus 32r. Okay. I am going to subtract 1024, which gives me 64r is equal to 2,112. And that would give me r is equal to 33 units. Okay. 8 is really basic. I know both of them are tangent and they share that common point r, so I can just say 49 is equal to x squared. Now you do have to be careful here, because if I asked you guys to solve this, I'm going to guess 90% of you would square root and you'd tell me that x is equal to 7, and then I would take a half point off, because when you square root, we should have our plus or minus there. Now, anytime you get that plus minus, you got to go back and see, does it make sense in your problem? So does it make sense to have x as a negative 7 there? Yes, because negative 7 squared does come back as 49. An example of where that wouldn't make sense is, like, let's say this was x plus 2. Positive 7 plus 2 gives me 9. That's perfect. But if I go negative 7 plus 2, that would imply that this entire segment would be negative 5, which doesn't make sense. Okay, so in that scenario, I would throw out the negative. In this one, I don't. Both of them make sense because we were squaring them and they both come back positive. Okay, so nice short little start to the week. Homework, give these problems a try.